Ah, okay.
And then Friday.
Okay.
Uh-huh. And then, yes, that one. The 2.4 to 2.5 over Q1. Oh, it's not letting you click on it?
It is not. Are you logged in?
No, I'm not.
No, it's not letting me click
on it.
on it.
What about Wednesday?
Yeah, it lets me click on that. You want to do that? Long synthetic division? Okay.
Yeah.
All right. Start with question 1. All right. Is your audio tab, it's still trying to connect?
Yeah.
Huh, interesting. Okay. Well, at least we have this option here. Okay. These are, you want to do this by synthetic or long, or do you care?
Synthetic.
Okay. So if I'm going to do it by synthetic, then I'm going to put my, hold on a second, sorry. Got what I was doing for a second. All right, let me write mainly in my window. So if, what goes in the box if I'm doing it synthetically? In other words, here I'll put my coefficients across the top, and we haven't talked about this before, but if sometimes you have to use a dummy coefficient. In other words, if there were no 9x there, I would have to put 0 in place of 9. You're aware of that?
Yes.
Okay. What goes in the box? Is it +1 or -1?
-1.
Yeah, it's the actual 0, not the factor. X plus 1 is the factor, but if that is a factor of this polynomial, then we will produce a 0 remainder. And that's how we'll determine whether it's a factor or not. Or we'll have some kind of remainder. So I know you know how to do synthetic, so I'm just going to do it quickly, speed things up. Bingo. That means x plus 1 is a factor of that polynomial. So our answer is what?
Squared plus 5x plus 4.
Correct. I guess I can put that in on my keyboard, huh?
Yes.
X squared is what? Like that? Yep. Plus 5x, whoops, you gotta go make sure you go right arrow, I remember that about this, plus 5x plus 4. With no remainder, I guess I should just leave that blank, huh?
Or do we put the 0 in, or do we just...
I don't know. Let's try. I'm going to leave it blank because there is no remainder. That's kind of one of the essences of the problem, is determining whether you have a remainder or not. So they shouldn't require us to put a 0 in there. Let me try that. I pushed enter. Didn't seem to do anything. No, I guess I do have to put a 0 in there. It wouldn't let me finish the problem without putting a 0 in there, but I think that is only because it's Excel. if this was on a test, you would never put the remainder in there like that. All right. All right. This one, there are also no dummy variables. I can do this two ways. I can do it by long division, or I can do it by synthetic division. If I do it by synthetic division, what goes in the box?
It would be 2.5, right?
Yeah, or 5/2. I think I would prefer to just keep it as ratios tend to work better when you get into higher mathematics. Putting 2.5 down there is not as good as putting 5/2, it seems to me. I mean, actually starting with trig is where using ratios works better. And this should give us the right answer. I haven't had a lot of practice at doing this. Let's see, that's 12/2 plus 5/2 is 17/2. Oh, now we get complicated, huh? And now we get 85/4. Wow. You have your calculator in front of you? Well, let's see. That's not a hard, that's actually not, yeah, it is. What's 9 times 85? What's 9 plus 85/4 in terms of fourths? In other words, it's, well, I know what it is. It's 36. 36 plus 85 is 121/4. And now when we multiply that, we get 605/8. That's 32/8. So we get 637/8 is our remainder. Now, the one interesting thing about this is this is probably the only time I've ever actually had to put in the remainder. Because most of the time, if it's not 0, you kind of ignore it. But in this particular problem, well, let's see if that's the right answer. So I got x squared
17/2x
plus 17/2. And here you got to make sure you hit that right arrow because the x can't be in the denominator. Plus 121 divided by 4. I don't see where I can simplify any of those. And the remainder is 637 divided by 8. Now let me look at that number for a moment. It adds to 16, which means it's not divisible by 9. Is it divisible by 8? I don't no, it is not. Okay, well, should we try that?
Yes.
Gosh, I hope it's right. No. Ah, interesting. Let's try it by long division and see what we did wrong. I actually had not tried a problem like this using synthetic division, but it's not going to be that hard to do with long division. Let me get it set up. 2x minus 5 divided into, oh, well, no wonder I didn't get it right. I got my wrong coefficients. I left the old coefficients there. You want me to go straight into, let's do long division, and then we can go back and do synthetic division. I apologize. I made a mistake. That was from the last problem. No wonder we didn't get the right answer. but let's try it. Synthetic division actually should work fine, but since we just did a couple of synthetics, let's try this method. Okay, so yeah, let me in fact erase all of this. Yeah, no wonder that wasn't the right answer. I'm going to leave it up there because we may want to check it. So let's do it by long division. What goes here?
My computer shut off again.
Do you have a piece of paper and a pencil?
Yes.
Okay. Write out the polynomial and divide it by 2x minus 5. The polynomial is 4x cubed minus 2x squared minus 12x minus 20.
So 4x cubed
minus 2x squared minus 12x minus 20. Okay. Now we're going to divide all of that by 2x minus 5. We're going to do it by long division. So what's the first term of the, see, we have a dividend, divisor, I guess that's the quotient we're talking about. What's the first term of the quotient? 2x squared. Okay. Always you got to, and then when you go to multiply it, remember we multiply the 2x squared by both terms. Make sure that first term is exactly the same. It always has to be. Now I'm going to subtract. What do I get?
Negative 10x squared.
I'm subtracting. I got minus 2x squared minus a minus 10x squared. One of the easiest mistakes that you can make in mathematics is to drop negative signs. The most important thing with long division is you're subtracting, not adding. So minus 2 minus a minus 10 is positive 8x squared. Bring down the minus 12x and repeat. The next term is 4x. Multiply that 4x by both terms. Now subtract those, you get 8x, bring down the minus 20, and now you get plus 4, and it gives you no remainder again. You're going to look at that first answer and think you're nuts. Alright, luckily we get 2 shots at it. Hold on a minute. Tighten this up so I can read it. Wow. I guess I can just backspace my way back to here, huh? Okay. 2x squared plus 4x plus 4 with 0. Ooh, don't want to put 0 in that denominator, do I? Would not like that. I know that. Ooh, doesn't even look. There. That should be it. Okay. Now, do we want to proceed or do we want to give a shot at synthetic division on this to make sure we get the same thing? In other words, can we use synthetic division when that divisor is of the form 2x minus 5? I'll leave it up to you. I don't know how many problems you have to do tonight.
Should we move on to the next one?
Sure. No, I have no problem with that. I suspect, well, let's try synthetic division on this one. So what goes in the box?
What is the problem?
Oh, you can't see it. I forgot. Here's the polynomial 15x squared plus 19x minus 7.
Okay.
Can you hear me?
Yes.
Divided by 5x minus 2.
5x.
Yeah. So this time I'm going to try synthetic division. What goes in the box?
2/5.
Let's try that. What goes up top is 15, 9, and minus 7. So I drop the 15 all the way down. Multiply 2/5 of 15 is 6. Add that is 15. I see what happens when you do this is it usually comes out all integers. Ooh. And that times that is 6. So I get minus 1 is the remainder. In other words, I don't know if you did it on your pencil and paper or not, but below the line I get 15, 15, minus 1. Is that what you got?
Yes.
Okay. Let's try putting that in. So it's, what's my answer? How should it look?
So it would be 15x.
Correct. Mainly that's what I was looking for, is to make sure you knew it was 15x, not 15x squared, plus 15, and then the remainder, the minus 1, goes in that remainder box. So that was the answer I just put in. I haven't clicked enter yet, but I got 15x plus 15 with a remainder of minus 1 over 5x minus 2. Sorry, that's not correct. Both your answers are incorrect. When a divisor has more than one term, the 4 steps used is it possible that you can't use synthetic division in these kind of problems?
Maybe, I guess you have to use like long for some of them then. And then
Well,
like,
that must, I didn't realize that. Let's try long division here real quick. I'll do it. 5x minus 2 dividing into 15, well, of course, the first number has to be 3, x squared. Huh, interesting. Okay, well, that's very interesting. Oops, 15x squared plus 19x minus 7. So the first term is 3x squared. That gives me fixed 15x cubed plus minus 6x squared. Hold on, let me back up. I wrote it wrong. Oh, now it says you left the room. Is it still trying to get it back in?
my computer is like shut off.
Why don't you reset? I tell you what, why don't you, all of our communication at this point is strictly through my phone. Go ahead and reboot your computer. That's the best way to go when you have problems like that. And we can continue working, but while we're working, your computer will reboot and you'll be able to log back on.
Yeah.
Okay. So when I do this long division, the first term is 3x, not 3x squared. Okay, and that produces 15x squared minus 6x. Then I subtract, I get 25x minus 7. And when I divide that, I get plus 5. And that gives me 25x minus 10. And I get a remainder of 3. So let me try putting that in. 3x plus 5 and the remainder is 3, positive 3. Is that what you got? I'm going to go ahead and hit enter here. It's our second chance, right? All right.
Okay. I don't know what's wrong with my computer, but it's glitching right now.
Okay. That gave me the correct answer. Okay. So what we learned, if I'd have read the instructions again, I would have realized, it says divide using long division. Okay.
Okay, so some of them we have to...
Well, the key is whether your divisor or not, I believe, whether it has a coefficient of 1 on the x term. The last two problems that we tried using synthetic division on did not. In other words, this is 5x minus 2. In other words, you can't synthetically divide it by 2/5, which is what we tried to do. Synthetic division does not work when your divisor is of the form 5x minus 2 or 3x minus 1 or something like that. So I guess you have to use long division. Yeah, I did not know that, but all right, let's go on to the next one. All right, let me just read it to you. Is that okay with you if we proceed this way?
Yeah, I'll just write it down on my notebook.
Okay, cool. So the polynomial, and this one also says use long division. So we have 21x to the fourth plus 27x to the third minus x squared, and that's it. 21x to the fourth plus 27x cubed minus x squared. Wait, and we're dividing it all by 3x squared plus 2. Now, where we have to use dummy variables are in both the divisor and the dividend. We could actually factor out an x squared from the top. It actually might make it a little easier, huh? In other words, we would then take our answer and multiply it by x squared. Let's see how this division works. I'm going to stick a dummy variable in here. So my divisor is now 3x squared plus 0x plus 2. And my dividend, I'm going to add a 0x and a 0. So I've added dummy variables in top and bottom just to make sure I have a variable for every degree. What's the first term in the quotient? In other words, what is 21x to the fourth divided by 3x squared? Are you still on the phone, Stacy? I don't hear you anymore even on my phone. Yeah, hi Stacy.
Okay, 7x squared.
Okay, cool. Now, and you put all the dummy variables in both the divisor and the dividend?
Yes.
Okay, so let's multiply that. We get 21x to the 4th plus 0x cubed.
And then plus
14x squared. And now we're subtracting. So 27 minus 0 gives us 27x cubed. Minus x squared minus 14x squared gives us minus 15x squared. I'll bring down that dummy 0x just to see if it matters. Repeat.
Then it would be
9x.
9x.
Now multiply by everything.
27x cubed, and then 0x squared. Yeah, 0.
Okay, and then I subtract and I get minus 15x squared minus 18x plus 0. And
5x.
negative, I think it's just negative 5, isn't it?
Oh, yeah.
Okay, and then let's see what our remainder is going to be here. That gives us that plus 0x minus 10. When I subtract, I get minus 18x plus 10. So my quotient should be 7x squared plus 9x minus 5. 7x squared plus 9x minus 5, and my remainder should be minus 18x plus 10. All right, we ready to try that? Is this my first try on this one? Yeah. Is that what you got?
Yes.
All right. Negative 18x plus 10. Let's try it. Good work. All right. So what we learned was pretty important here. Was something that I wasn't 100% sure of. Can't use synthetic division on these kind of problems. And you do need dummy variables in all positions in both the dividend and the divisor. Okay, this is relatively easy. Oh, that's because they want you to use synthetic division on this one. You're still not back on GoToMeeting? Okay.
It's glitchy. Like the screen has like white bars on it.
Wow, that doesn't sound good at all.
No, I think it's broken. I don't know.
It does sound kind of broken. It's like the black screen or the blue screen of death.
Yeah.
It's interesting that should happen. I have a funny story to tell. When I was forced to upgrade to Windows 10, and in the process of backing up my hard drive, my monitor went out. But it didn't go out 100%. It came on and then went out after about 10 seconds. And you cannot believe how much of a problem that was for me. It forced me to think my computer was busted. So I went to Best Buy and I bought a new computer. Came back, tried to hook up my new computer to my old monitor, which is busted, and I don't know that it is. And I get the same problem. So I got to take everything in. He hooks everything up. My monitor's bad. He hooks up a new monitor to it. It's fine. So it's all I had to do was buy a new monitor, and I hooked it up to my old computer, and everything was fine. But it was the toughest thing to diagnose because it happened to go out at the moment I finished backing up my hard drive, which is a very unusual spot for your monitor to just go out. And figure it out that that's what's happened. So I don't know, but it doesn't sound good with your monitor. And that's your monitor on your laptop, right?
Yeah, I don't. Weird. The screen's just all like bars, like white and black, and then.
And you tried rebooting. When you tried rebooting, did it do anything? Did it reboot? Did it boot up?
No, it just keeps going back to like the black screen.
That's not good at all. You're going to need to take that in somewhere.
Yeah.
I don't suppose you can use your mom's computer until then, or?
No, she's not home right now.
All right. I think we can probably finish these up by phone.
Yeah, and then have it fix the bar next session.
Yeah, okay. So this problem here says divide using synthetic division, and it's 4x squared plus 3x minus 10, and I want to divide it by x plus 4. So what goes in my box?
-4.
Okay. And then I'll go ahead and do it. Bring 4 down, minus 16. Now I'm adding. Multiply that. I get 52. I get a remainder of, what do you get for a remainder?
40, wait, do we subtract it? No, yeah, so 42.
Adding. 42, that's what I get. Now, notice why synthetic division works. This is worth knowing. When we use long division, this would say x plus 4, right?
Right.
And I would be subtracting at every step. Well, by changing that plus 4 to a minus 4 is what allows us to add. That's why synthetic division turns it into adding. The variable doesn't matter. You don't need the variable to be part of the process. But that's why we add in synthetic division and we subtract in long division. So let me put this.
4x minus 13 with the remainder 42.
It's not 4x squared though. Remember that if I'm dividing a quadratic by a linear, my first term has to be x, or 4x, yeah. 4x plus 3, excuse me, 4x minus 13 with a remainder of 42 divided by x plus 4. That's good. Next problem. Wow. This is one of the few subjects where I can actually do it by phone and I don't need my drawing tablet. But I'm telling you, there's not very many subjects that fit that description. This one, they want you to do it synthetic division. And the polynomial is x cubed plus 9x squared minus 3x plus 7. And the divisor is x minus 3.
Okay, so the first one is x squared.
All right. I'll tell you what. Go ahead and do the synthetic division on your own. I'll do it on my own. You tell me what you get. We'll make sure we have the same answer.
Okay.
Wow. What do you get for an answer? What should I type in these boxes here? Hold on. What'd you get?
Oh, I'm not done yet.
Oh, okay. Sorry. So when you get done, tell me what your quotient is.
Okay.
Okay, I got 12x. Look at your synthetic division. The second step, you should be adding 9 and 3.
Oh, I subtracted it.
Right, that's what I figured. That's the one problem with doing a combination of long division and synthetic division, is it's easy to get mixed up between the two. Just always remember, long division, you're always subtracting. Synthetic division, you're always adding.
That means that this,
Yeah, that changes all the numbers for sure.
yeah, 30x and then 30. X squared plus 12x plus 30?
You get 33. You multiply 3 times 12, you get 36. Add it to minus 3, you get 33. Multiply 3 times 33, you get 99 as the last step. Add it to 7, you get a remainder of 106. Make sure you do it before I put it in here. Make sure you verify that that's correct.
Okay, I got it.
You got that? All right.
Yeah.
I'll put it in. That's good job. Next one. Use synthetic division for this one. Now, this one's a little, nah, not really. Okay, it's the polynomials x to the 5th plus x to the 3rd minus 2.
We have to fill in 0.
Yeah, so our top should read what? 1, 0, 1, 0, 0, and minus 2. There should be 6 numbers across the top, I think. 1, 0, 1, 0, 0, minus 2, right? Because we have 2 dummy variables. Okay, and the number that goes in the box is a 1. Go ahead and do the synthetic division on your own. I'll do it. Make sure we get the same answer.
So I got x to the 4th plus x to the 3rd plus x squared plus 2x plus 2. Wait, no, 2x squared. Oh, wait, no.
Yeah, my bottom numbers are 1, 1, 2, 2, 2, 0. Okay, that's what I got. Let me put that in.
Yeah.
All right.
X to the 4th plus x cubed plus 2x squared plus 2x plus 2.
With a remainder of 0. Well done. All right, this problem says, use synthetic division and the remainder theorem to find the indicated function value. And they give you a function. Let me read it to you. The polynomial is 3x cubed minus 12x squared plus 7x minus 7. And they want you to evaluate it. In other words, they want, what is f of 1?
What?
They want you to figure out, using synthetic division, what f of 1 is. In other words, the easiest way to figure out f of 1 would be what? Just plug it in for x, right?
Yeah.
To me, that's the easiest way. But you can also do it using synthetic division. and the remainder theorem. Well, let's try doing it using synthetic division. So across the top, we're going to have 3 minus 12 plus 7 minus 7. And then in the box goes that number, 1.
1.
Okay, let's do it.
Okay, 3 and 9, 16, -9.
That's what I get. So I get, so why is this the way to figure out that value? In other words, I know what the value is. The value is 3 minus 12 plus 7 minus 7. So the value has to be minus 9. I guess it's that remainder. That's all you need.
Yeah, that's the same thing you get when you just plug in.
Yeah, it is. So, right. In other words, when you use synthetic division, whatever your remainder is that value. And so if that remainder was 0, it would tell you that 1 was a 0 for that polynomial. But if it's not 0, it actually allows you to figure out what f of 1 is. I don't think it's a very efficient way to figure out what f of 1 is. In other words, it's far quicker to just plug it in, but it's interesting to know that that works like that. Okay, the next problem is very similar, except the polynomial is, you ready?
Yes.
X to the 4th, and they want us to use synthetic division also, plus 3x cubed plus 3x squared minus 8x minus 6. I'll race you to come up with the answer.
Okay, and then what are we dividing it by?
Oh, not much, not very fair if I get a head start, huh? 7. F of 7 is what we want to calculate. What is f of 7? Oh my goodness. I might have to get my calculator. Did I do something wrong here? 7 times 1, 10. 7 times, no, 73. What's 7 times 73? I do have to get my calculator out.
511.
511, yes. And then when I subtract 8, I get 503. Multiply that by 7, I get 3521. Subtract 6 from that, and I get 3515. So that should be what f of 7 is. 3515. That's what you got?
Yeah.
Nice work. All right, let's see. Use synthetic division to divide this cubic by x minus 3. Use the result to find all zeros of f. Okay. So the polynomial is x cubed minus 15x squared plus 68x minus 96. We're dividing it by x minus 3. So 3 goes in the box. Bet you this comes out with a 0 remainder. Yep. You know how I knew?
What?
You know how I knew it was going to be a 0 remainder?
How?
Because they said use the result to find all of the zeros. Well, the only way I could do that is if this was one of the zeros. And the only way this could be one of the zeros is if my remainder came out to be 0. Okay, so here's what I have. I have x minus 3 is one of the factors. What's the other factor? X squared?
X minus 8 and x minus 4.
Okay, I'm still on x squared minus 12x plus 32, and that factors into x minus 8.
X minus 4.
So our 3 zeros are what?
8, 4, and 3.
Correct. Now, the question is, how do I put that in? Use the result to find all zeros of f. So it's going to be a multiple part. So the first thing I have to do is put the first answer in. So that's x squared minus 12x plus 32. Good job. And now it's going to probably ask the rest of the question. The zeros of f are, use comma to separate answers, so we have 3, 4, 8. Fantastic. All right, let's see. The following problem, this number 11, says solve the equation x cubed plus 2x squared minus 5x minus 6 equals 0. Let me write that on my paper for my sake, not yours so much, but I have a hard time solving these unless I have it staring me in the face. Given that 2 is a 0 of that function. Notice, first of all, notice that that cubic cannot be solved by grouping. That'd be the very first thing I would look for.
Okay.
Which means that if I had to solve the whole thing on my own, I'd have to use that P over Q rational factor theorem, right?
Use all the factors of the first and last.
Right. But we don't have to do that because they gave us a 0. They said that 2 is a 0 of this function. So how can I solve for the other zeros?
Synthetic?
Yeah. In other words, we're going to just merely use synthetic division, divide this polynomial by 2.
What was the polynomial?
X cubed
Okay.
plus 2x squared
Okay.
minus 5x
Okay.
minus 6.
Okay, and then divide by 2.
Synthetically divide by 2, which gives us 1, 2, 4, 8, 3, 6, 0. Okay, so now that means the resultant quadratic is x squared plus 4x plus 3.
So x plus 3x plus 1. So the zeros are -1, -3, and 2.
I wonder if you have, I don't think you have to put them in order. I did one not in order the other day and it worked fine, but I'll put it in order. -1, comma, -3, comma, 2. Actually, that's not in order, but that should work. Well done. Well, we're making, this one's going to be hard to do because it's got a graph in it. It says use the graph to determine a solution. We only have 5 minutes left. Shall we skip this one? Hold on, maybe we can do this. Use and verify the solution.
We can skip it.
Well, we may not have to. Hold on. solve the polynomial equation. This equation can be solved by grouping. First of all, it says use the graph to determine a solution of the equation. Well, the graph tells me that one solution is x equal 2. Use synthetic division to verify that this number is a solution of the equation, then solve the polynomial. We can do this one. So,
we have the polynomial?
Yeah, the polynomial is x cubed plus x squared minus 4x minus 4.
Okay.
Now notice why I can solve that by grouping. The ratio of the coefficients of the first two terms is the same as the ratio of the coefficient of the last two terms. So I could rather easily solve that without using anything fancy. But their instructions say use the graph to find the one solution, and it's clear x equal 2 is one of the zeros, and then use synthetic division to solve for the rest of it. So I'm merely going to do the same thing we've been doing. I'm going to divide that polynomial synthetically by 2. And what I get is
X squared plus 3x plus 2.
right. So I get x minus 2 is one factor, and the other factor is, it must be x.
-2 and -1.
Yeah. So my three zeros are 2, -1, and -2. Okay. Now, 2, comma, -1, comma, -2. Is it worth your time to have me show you how to solve that by grouping? Ooh, hold on. I got the wrong answer.
What did we do wrong?
I don't know. I'm trying to figure out. Let's say I put in 2, comma, -1, comma, -2. Well, let's solve it by grouping,
Okay.
since the other didn't work very well. Hold on. Okay, so you got your polynomial written across the top?
Yeah.
Okay, what we want to do is put parentheses around the x cubed and the x squared terms.
Okay.
So we now have x cubed plus x squared in parentheses,
Okay.
and then a minus sign, and then what parentheses, what's the last term going to be, or the last two terms? 4x, but notice that it has to be plus 4.
For 1 negative.
Right. In other words, make sure that after you group it and you put your parentheses around it, that you have not changed the function, that you're still looking at exactly the same function. Now, on the first set of parentheses, I can factor out an x squared, leaving x plus 1.
Right.
And on the second one, I can factor out a 4, leaving x plus 1.
Oh, and then you go x squared minus 4 in parentheses, and then x plus 1.
Right. So I get the same three factors I got doing it the hard way, because that's x minus 2 and x plus 2, which means I must have put it in wrong. Which solution of the equation can be determined from the graph? Well, I guess it helps if you read the problem, which I didn't do. gosh, now the question is, do I need to put in x equal 2 or just 2?
Well, we do have 2 more chances.
I'll try just 2. Well done. Okay. What are the other solutions of the equation? Minus 1, minus 2. Minus 1, comma, minus 2. Excellent. All right. But you notice how we did the grouping.
Yeah.
In other words, whenever you have a cubic that lends itself to grouping, it's almost always the easiest way to do it. And it gives you all the factors. In other words, you don't need to produce 1, 0 and then divide it to come up with the other 2. So, yeah, I guess that's a good place to stop, since the next problem is a table that I would have difficulty describing to you. And
So
it's...
when do you know what to group again?
Oh, sorry. When the ratio of the coefficients of the first 2 terms is the same as the ratio of the coefficients of the last 2 terms. Notice that in that problem we had a 1 and a 1, so that ratio is 1, and then we had a minus 4 and a minus 4. That ratio is also 1. That's when you can group. The toughest part about grouping is making sure that when you put parentheses around it that you don't change it, because it's really, really easy to make that mistake, where in the second set of parentheses you might end up with 4x minus 4. The real trick is that when you go to factor after that, if you can't factor out that binomial, you've made a mistake. Okay? And so that's kind of a check. In other words, you can always go back. If you know that you should be able to group it, then after factoring, you should have 2 binomials that are the same. In this case, it was x plus 1, x plus 1. And then you factor out the binomial. Okay. Now, I accidentally went to number 13 here. Should I just hit save?
Yeah.
Okay. Yeah, I didn't put in any answers, so I hit save. You've got the first 12 done. And it's ready for 13. Okay? You're welcome. And wow, I'm pleased we were able to finish the session. That's interesting.
Sorry about my computer.
No problem. It actually worked out far better than I would have thought it would. So, all right, Stacy. Talk to you next time.
Thank you. Have a good day.
Bye-bye. You too.